Hello students, the question says, see the diagram, area of each plate is 2 meters square and D equals to distance between the plates is 2 into 10 power minus 3 meters. A charge of 8.85 into 10 power minus 8 coulomb is given to Q. Then the potential of Q becomes, okay. So the plates are arranged in this way and we have given some charge to Q and we need to find how the potential of these plates becomes. See, this is a fancy way to represent that the potential at R is zero potential, the potential at P is also zero potential. So when both are at the same potential, we can actually connect these 2 points. Let us see how are we supposed to solve this. So this is given as P, this is given as Q, and this is given as R. Since these two are at same potential, we can directly connect P and Q. This will form a capacitor C1. This will form a capacitor C2. So let me redraw it. This PQ, PR can be directly connected. So P comma R are one point and Q is a different point. So we have one capacitor between P to Q. We have one more capacitor between Q to R. So these are the two capacitors that are there. This is also Q. This is also Q only. And this is C1. This is C2. Now these two are grounded. So they have same potential and let us assume these are grounded. Now the author is saying we are supplying a charge. Let us assume a charge Q is supplied into the location of Q. If you supply a charge Q here, this charge Q will travel and distribute it in these two capacitors. And since they are in parallel, so the charge would be distributed here C1 comma C2 are in parallel. Now you are supplying a charge Q to this side of the system. Here C1, C2 are in parallel. Since they are parallel, we can write V is constant. Since V is constant, we can write, let me call this Q1 and Q2. Charge is proportional to C1. So we can write Q1 by Q2 equals to C1 by C2. Not only that, we can even write Q1 plus Q2 equals to Q. We know sum and we know ratio. So based on this, I'll do it in the next page. We can write Q1 equals to its corresponding ratio divided by sum of ratio into capital Q. So let us find what is C1 and C2. So C1 is epsilon naught A by D. C2 is epsilon naught A by 2D. So let me call this as C. So C2 would become C by 2. So if I substitute that over here, C by C plus C by 2 into capital Q. So we get 2C by 3C into capital Q. So it would be 2Q by 3, small q. So this is what we get. So we finally got Q1 equals to 2Q by 3. So I'll take this diagram. We got this value as 2Q by 3. We got this value as Q by 3. Now what I will do is I want potential difference between this point and this point. I want potential of Q. If I want potential of Q, let me call X is the potential of Q, Y is the potential of P and R. From the diagram, we can clearly see they have been earned. So we can say the potential of P and R both are 0. So this point, potential of X is 0. So we can write Vx minus Vy equals to Q1 by C1. So we can simply write Vx, Vy is anyway 0, is simply Q1 by C1. So Vx would become Q1 value is 2Q by 3 into C1 value is 1 by epsilon naught A by Now we'll substitute everything in this given equation and we'll solve the problem. So V at x, or which is also potential of Q, is 2 into the charge supplied is 8.85 into 10 power minus 8. The value of D is given as 2 into 10 power minus 3 divided by 3 into epsilon naught value is 8.85 into 10 power minus 3 into D value. A value is area between the plates is 2. So if we solve this, we can cancel these two. We can cancel these two. So we finally get 20 by 3 because 10 power minus 12 minus 11. So plus 12 minus 11, 10. So 20 by 3. So you'll get 6.67 volts, which is our option C. I hope you understood how we solved this problem. To explain you, it took some time, or else we could have solved this very fast. As soon as you realize that these are connected in this way, you will immediately redraw the diagram. PR are one point, Q are one another point. So you have supplied charge Q to this. So the charge would distribute in this way. Here Q1 and here Q2. Since charge is flowing in this direction, you can assume that Q is at higher potential and the PR are at lower potential. And once we got this, we found the value of Q1 and Q2 and we solved the problem. Hope you understood how I was solved. Thank you.